This video is going to be a quick review on ionic compounds and just in general what compounds are. So just remember, chemical bond is a force that holds two atoms together. Now there are two ways that can happen. We already know that it's ionic in covalent compounds, whether you share or steal an electron. But remember that there's an attractive force between the nucleus and the negative electrons. And then if the nucleus of one atom is attracted to the electrons of another atom, then that links those atoms together. So that's due to shared electrons. When the nuclei of two atoms are attracted to each other's electrons, that links those two atoms together in a covalent bond. So that was all chapter 6, Lewis structures, the shared dots, linking together, drawing those bonds. Now, the other way is a positive and negative ions. When one atom steals the electron from the other atom, the two atoms become opposite charged, and we know that opposite charges attract, just like opposite ends of a magnet attract. That is an ionic bond, and that's what we're in is chapter 7 right now. So an ionic bond, let's spend a little time on this. So ionic bonds form crystal structures where the positive and negatives attract, so they align in a way that the positives and the negative attractive forces are maximized. So the fancy definition here is a chemical bond resulting from the electrostatic attraction between positive and negative ions. This fancy thing here, electrostatic attraction, is basically opposite charges attract between the positive and negatives, the opposite charges there. So it's a bond formed when atoms gain or lose electrons. The electrons are transferred or stolen. You can think of it like that. So we talked about the bully on the playground. When you got one atom that's really desperate for electrons, very, very highly electronegative, and it can steal electrons from the weaker atoms. And that's typically a nonmetal and a metal. The nonmetal steals from the metal, or a polyatomic and a metal. So now we know what a polyatomic ion is. So if you see a metal and a nonmetal, or a metal and a polyatomic, you can assume that it's an ionic compound. So we already talked about last chapter how an ionic compounds form. They arrange, and I already said it in this video, to maximize the attractive forces between the atoms. The individual attractive forces between the atoms is very, very weak. So that's what I mean by weak bond. But collectively, all those little weak forces add up to a very strong crystal. So like NaCl, it packs together like this. Again, notice the Na, the positive sodium, is surrounded by 4 negative chlorines. And if this is a 3D structure, there'd even be a chlorine in front of this and behind it on the screen if you're looking at it 3D. So it's surrounded by negatives. And then the chlorine is surrounded by the positive sodiums. So there's no individual bonds, it's just held in place due to packing and those opposite charges just collectively holding the crystal together. And that strong energy holding the whole crystal together is called the lattice energy. It's the energy holding the ions in place in the crystal. Now there's different ways that atoms can pack. You can see there's some different structures here. This is a complex packing arrangement between calcium and fluoride. And then you got oxygen and magnesium. They pack in a different way. If you move on in chemistry, these are called unit cells, and you learn there's different ways they pack. That's called like cubic close packing, like face-centered packing. There's all sorts of different packing arrangements that the atoms can make. We don't spend any more time on it than this brief mention. But the way that they pack depends on the charge of the atoms. Are they both +1, -1, or is it a +2, -1 charge? You know, the ratio of the charges of the atoms. And then the size of the atoms. Is one atom significantly larger than the other one? Are they both the same size? So all those things contribute to how they pack together and the way they arrange themselves in their crystal structure. So when we write a formula for an ionic compound, we call that the formula unit. It's the simplest collection. It's the lowest ratio of those atoms, the way they pack together. They pack together in a 1-to-1 ratio, a 1-to-2, a 2-to-1. What ratio do they pack in? So we abbreviate FUs, and they're always written in the lowest ratio. So an example, let's see here. We've got sodium chloride. Let me quick get my pen out here. We've got a crystal structure. So the crystal structure of sodium chloride, if you were to count it all up, there would be a 1-to-1 ratio of NAs and Cls. You wouldn't count up the crystal and say, oh, there's a billion sodium atoms and a billion chlorine atoms, and then write Na, let's say 10,000, and then that's Na, and then Cl 10,000, because there's 10,000 of each atoms. You would never write out a formula like this, even though that's really what's in the crystal structure, is millions and millions of each of them. What you do is say, okay, it's a 1-to-1 ratio, so you write NaCl, which I believe, nope, I didn't put that in there. So you'd write NaCl because there's a 1-to-1 ratio. So this is called a formula unit. It's telling me the ratio of the different atoms in this crystal structure. So that's what we mean by formula unit. And then hint, you got to make the positives equal to the negative charges. So in the last video we talked about oxidation numbers. Remember the oxidation numbers has to add up to 0, or the sum of the charges has to add up to 0, so the compounds are neutral. And we'll do a little bit more of that in a future video when we write the formulas. But for now, you should know how to write oxidation numbers, and then we'll work on writing formulas out later.